Now, 4.1, today we're talking about angles. So radian and the degree are the two things we want to focus on for today. And we are talking about the measurement, how to measure angle. Now, when we talk about angle, basically we have two sides. So one angle starts from initial side. And then end with the other side we call terminal side. Terminal side. So between these two, start from initial side and it form an angle. Let me use other color. So start from the initial side, keep going to the terminal side. This angle has a direction, so we call it theta. We usually use this Greek letter to talk about an angle, theta. Now, if you have angle go this direction, then we say it's a negative angle. So going up is a positive angle. Going down is a negative angle. But right now we don't talk about the direction yet. Okay, we simply talking about if one angle started from initial side and keep going up to terminal side and there, and then it is an angle. We call it theta. Now, if an angle start from same initial side, start from the same initial side and then goes to the same terminal side. Are you sure there's only one angle be like that? From initial side goes to terminal side. Looks like there's only one angle, but actually you may go this direction, right? Let me change to other color. Other color, you can change it to green. Okay, so from the same initial side, and we go clockwise, you find a bigger angle. Then looks like the black color looks more like an angle. And the green color, if you say this is also an angle, doesn't look like, right? But actually, it's also called an angle. So with the same initial side and the same terminal side, you may have two different angles. Now, number one, we want to learn a new vocabulary word. Coterminal. Two angles that have the same initial and the terminal side are coterminal angles. I think I should put the angles there. Coterminal angles. Okay. So means these two angles, they share the same initial side and they share the same terminal side. This is pretty easy definition. So if you have alpha, sometimes we use alpha and beta to denote the angle. So alpha, beta, they start from same initial side and end with the same terminal side. The other situation is if you have angle alpha, the other angle, if you goes to the same direction, like alpha goes to counterclockwise. And the beta also go counterclockwise. But keep going. So you start from here, go one circle, and then go more than one circle. So basically, this beta looks like 180 degree plus alpha. So 180, no, not 180, sorry. One circle, how many degree? 360 degree. 360 degree. So beta basically goes 360, one circle, and then keep going, alpha degree. If alpha is a degree, pretend is a degree. Because pretty soon we are going to talk about something not major with degree. But right now I can only use degree as an example. In this case, you have looks like you have same angle, but beta maybe one circle more than alpha. Maybe you can go 2 more circles, 3 more circles. So all over the trigonometry, we are going to deal with the degree or with the whole circle, 2 circles, 3 circles. You wrap around the circle many times. So that's number 1 questions. Now, next, number 2, we want to learn a new system of measurement. How you measure an angle with another system, we call it radian. So degree, we all learned that long time ago. And what radian means? So pay attention on this big circle. So I have a angle here. I have an angle here. Pretend the radius of the circle is r. Radians. The radian is r. Now, how I decide an angle here? So if one angle open from initial side to the terminal side, if the opening happen to be same size, same distance, if you straight up this curve, it happen to be r. In this case, we call this angle is measure of 1. We say angle equals to 1. It's kind of weird. There's no unit. So if you insist to write down unit, we say 1 radian. That's how you denote. It's not 1 degree, it's 1 radian. Now, what we want to learn is how you convert 1 radian becomes to how many degree. That's interesting, right? 1 radian equals to how many degree? So we need to learn some skill to convert a radian to become degree. How you convert a degree to become radian. But first, you have to fully understand what radian means. So I kind of set the definition for you. 1 radian, when inside a circle, you open an angle, and the opening is the same size of the radian. Then we call this 1 radian. Now, usually, if you have angle and then you one angle inside a circle, we said this angle will open and intersect with the whole circle an arc. This arc, the length of the arc, the measure of the arc, or the length of arc, we call it S. S. So if the S equals to R, we call it 1 radian. Then how about if I have another angle? Okay, start from here and keep going up there. Okay, and keep going there. I would like to know how many degree, not the degree, how many radian here. So if this angle, we call it alpha, and how many radian. So it depends on how big the opening is. If the arc S, then how do you know the angle is how many radian? So the formula will be like this. S divided by R. You want to check every one R, you have 1 radian. So that's the radian. Okay. S divided by R. You can check how many radian you have. For example, if you have a unit circle, for example, this radius is 1. And then I have a circle. And the open arc here, S equals to 2. So it means here we have 2 radius, right? 1 radius, 2 radius here. So each 1 radius, we call it 1. The angle is 1 radian. And you have another 1 radian. So total, when S equals to 2, then the theta is 2 radian. Okay? Now, if you have a bigger circle, if I have a bigger circle, let me try. If I have a bigger circle, and if my radius is 2, and if my radius is 2, I open my angle theta. And if this arc had the size of the length of the arc happen to be 2, then obviously if you have same length of the arc, but because it's in the smaller radius, so this arc S is 2 radian. But if your radius is 2, then in this case, this angle so this angle will be just 1 radian because the open arc, this arc, is the same size of the radius. So just 1 radius length. So we call this angle is 1 radian. R-A-D-I-A-N. Now, how you really calculate? This is the formula. So if you have the length is 2, and the radius of the length of the radius is also 2, then you have 1 radian. Okay? You have 1 radian. Now, if your open arc is 2, but your radius is only 1, then the angle will be 2 radian. So that's how you measure the radian for an angle. So after all the explanation, in the end, I would like you to memorize this formula when the question asks you how to find the radian instead of the degree. Now for the same angle, you may measure by degree or you want to measure by radian. But on the test, you need to answer according to the requirement from the instruction from the test. So 1 radian is the measure of a central angle. What the central angle means? It means the angle we keep talking about, the angle theta, that intercept an arc. So the arc, we call it S. So the length of the arc, we call it S. And the radius R. The formula theta equal to S over R. So when R equals to 1, then theta happen to be same. So theta is S radian. Okay, you can just use formula. And sometimes in the book they would like you to memorize theta S equals to R times theta. So sometimes they ask you what's the angle, then you use this formula. Sometimes they ask you if my radius is 2 and my angle is 1 radian, how you measure the length of the arc, then you use this formula. So if you multiply R on both sides, right, and cancel out R, so you have S equals to R times theta. S equals to R times theta. That's how you measure the length of the arc. So we are going to use these two formulas, depends on what they ask you. Now keep going. Another formula. We have 2 more formula here. So let me read the question first. I give the answer first. The linear speed of a particle is the ratio of the arc length traveled to the elapsed time, and the angular speed of a particle is the ratio of the change in the central angle to the elapsed time. What this means? Basically means when we are measuring the speed of a movement, we use 2 different systems. Sometimes we use the distance to measure how fast a particle moves. Sometimes we use angle. So if you have a circle, okay, and you have a particle move, let me use other color. Here, one particle move, okay, oh, okay, sorry. Okay, yeah. So one particle move along the circle to here. Say in 25 seconds. In 25 seconds, this particle move. For example, we say 3 feet. Then obviously, how you calculate the speed? The speed will be the length of the arc, right? Length of arc, 3 feet per 25 seconds. That's how you measure the speed. It's so obvious. We learned that long time ago. So the length of the arc, we use S. Divide by the time. That's the, we call it linear speed. Here, how fast. But there's another way we can measure is if you measure by the angle. Okay, so there's a center and there's an initial side. Okay, so okay, the initial side, and then keep going. The particle go around the circle and move. So it will create an angle theta. Now, if we don't use the length of the arc to measure the speed, instead we use the angle. So in 25 seconds, actually you go through how many degrees? Say this angle is about looks like more than 100, right? It's more than 180. We say 200 degrees. Okay, so if we measure by the central angle, like the speed is 200 degrees for 25 seconds. In 25 seconds, this particle move 200 degrees. So this is another way to measure the speed by the angle. If you measure the speed by angle, we call it angular speed. If you measure the speed by the length, then we call it linear speed. So that's number 3. Number 4, the area. So today we are going to learn so many formulas. The area of a sector of a circle with radius r. So say this radius is r. And the central angle is theta. And right now, our angle measured in radian. Now, what's the formula? So if the angle measured by degree, you cannot use this formula. Understand? This formula only when the angle is measured by radians. That's very important. Now, you don't need to memorize formula without understanding anything, right? If you understand the formula, basically you don't need to memorize the formula at all. So let me show you. You have to always memorize one thing is if you have one circle and the radius is r. One circle has how many degrees? One circle is 360 degrees. 360 degrees. We call it 2 pi radian. Why? Because the circumference the circumference is 2 pi r. The formula for the circumference is 2 pi r. So the whole circle has how many degrees? Whole circle S equals to the circumference. And divide by r. S divided by r is the angle by radian. Remember, we have the formula here. S divided by r equals to the angle in radian. Now, if you reduce the r, then the whole circle, the whole circumference, if the whole circumference is the one circle, one angle, then this angle in radians, you reduce r. Then this angle measure in 2 pi radian. So one circle 360 degree actually is 2 pi. If 180 degree, then divide by 2 is pi radian. And the area, because right now we are talking about the area. The area of a circle is 2 pi r. You have to memorize that. Area of the circle is 2 pi r. So you want to use these two facts. Which two facts? Here. The circumference is 2 pi r. And the whole circle has how many degree? How many radian? 2 pi. And the whole area, the circle, the area for the circle is 2 pi r. Now, when you want to find the area of a sector means this. This means a sector. So many definitions here. If you took a geometry before, then everything is already you learned before. But I assume our Oroni students probably didn't learn geometry before, so this will be new to you. So I need to reteach everything. If you already learned geometry, then probably it's easier for you. Okay. I will finish number 4 at the end of this video because it's already take too long time, and then the rest of the question I will keep going on the other video. But let me finish this one first. So yeah, okay, I have some example for you. Now first, how you find the area of just one portion, or we say one sector. First, you compare this angle theta compare with 2 pi. The whole circle has 2 pi. Is what's the fraction? What's the portion compares to the whole circle? And then you can multiply with the whole area. Like if this angle is 1/3 of the whole circle, then the area will be 1/3 of the whole area for the circle. So you just use theta divided by 2 pi. So if answer is 1/3 or 2/5, depends on what's the fraction, then this fraction you multiply with the formula of the area. The formula of the area of the circle. Then you can find the area for this sector. Okay, I will end number 4 here, and the rest of the classwork I will do it next time. So thanks for watching. See you next time.